Well, hey, engineering students, if you were gone last week on Friday, you missed some information about different types of holes and how to create them in OnShape. So real quickly, I'm taking a look at 1.3.2, making holes in CAD. This is on your PLTW page. So if you're wanting to keep up with the curriculum, this is where it's at. So what types of holes might we encounter? We may encounter simple holes, counterbores, and countersinks. Each type of hole is classified as a through hole or a blind hole. The difference is a through hole, spelled this way, or THRU, is a hole that extends totally through the part. A blind hole is a hole that extends part way through a component. So it has a specific depth and it ends somewhere inside of an object. So the type of hole, like the simple or the counterbore or the countersink, that type that gets used depends on the purpose of the hole and the hardware that it might need to accommodate, like a screw or a pin or a bolt head type. So a simple hole just is one diameter all the way through, or the same diameter through part of the object. The counterbore has this extra cut around the top of the material to accommodate a bolt head. So looked at from the side, if we were to chop the object up so that we could look at it, it would look like a little rectangle at the top. Countersink is a different type of cut, also at the top of the object. It goes down at an angle, and so it looks kind of extra round or just kind of this unique shape because of the angle at which it is cut down. This accommodates a screw head. As you can see, the profile of it looks just like the top of a screw. Okay, so hole notes. This is the type of thing that gets put into a multi-view drawing or other spec sheet, and so there are some technical notes types things that you'll want to take a look at, like the symbol for diameter. We've used that before, but now we also have a symbol for depth, because if it's a blind item or it has a counterbore, it will have a specific depth. Countersink, this is the kind of V-shape symbol for countersink. It looks just like the top of the screw head. And counterbore is that rectangular look that we saw from the side. So how about some examples? So right here, the hole note that you would see on the spec sheet would look like this. The top row is everything about the hole itself. So this is the main barrel of the hole. It's a diameter of 0.375 and has a total depth of 2. So that's, again, from the top of the part. In addition to that, there is also a counterbore at the top of the material. It has a diameter of 0.75 and it has a depth of 0.5. So something to keep in mind is that the overall depth of 2 inches, that includes the counterbore. So we just kind of measure everything from the top of the material or the top of the part. So this kind of shows the different diameters that you'll run into. It also might have a point at the bottom, and the point part is not measured. This is what happens when you drill something out. The point of the drill bit, right, goes a little bit deeper. Okay, so let's try to make this specific hole in OnShape. So in OnShape, I have this block made, and on the front of the object, I'm going to make a sketch. And on this front, I'm going to place some different points. So just a point, and I'm wanting to like kind of center it up, so finding the midpoint there. And I'm just going to put a few points all on the same horizontal line as each other. Okay. And you can certainly dimension how far apart you want these points to be from different places. So that is something that you'll have to do based on the worksheet that we've been working with. So again, you can dimension from point to point and so on. So all of these points, right, they're nothing, but what they are going to be for us is the center of these different holes. Because what we're not doing is we are not creating circles and extruding. No, instead, we are going to use the actual hole feature to put all of these specific simple countersink or counterbore hole parts in place. So once I click on that hole, I need to select one of my centers. And it defaults to whatever I may have used last. And so Okay, that's fine. But what am I doing here? This is a whole note for a counter bore. So I do want to make sure I'm on counter bore, and it is. And some things we're just going to have to leave as default, right? Clearance, size, fastener, fit. Okay, we're going to leave that as default. But if we hover over this image, it's asking us about diameter. So this is the diameter of the main hole. Okay, so back here, the diameter of the main hole is 0.375. So we're going to change that to 0.375. And okay, start from part, sure, blind. Okay, is my main hole a blind hole? Yes, because it has a specific depth. It's not going all the way through the part. So now I have 3 more measurements to put in, right? If it was a through hole, I would change this to through all, and then I would have fewer measurements to include. Okay, but it is blind. So what's next? Well, this image is the diameter across the counter bore. And if you hover over the kind of line there, that's exactly what it says. So the counter bore symbol has a diameter of 0.75. So one important thing is that that number, the counter bore diameter, will always be bigger than the diameter of your actual hole. If you get them turned around and you type in the wrong number, it will give you an error. Okay, next up, this is showing the depth of the counter bore, and if you hover over it, that's exactly what it says. So depth of the counter bore is 0.5, so we'll change that. And then asking about the depth of the overall hole, the main hole. So now back up to that top row, that main hole has a depth of 2 inches. So change that to 2. Leave this at 118 degrees because that's talking about the very tip of the object, right? You can kind of see that, yep, it's pointy down there. And so this is your counter bore. It has room for that bolt head at the top, and that's what that looks like. So green check that. And then one thing that a student noticed on Friday was that if you hover over the hole that you just made in your features panel, you can see exactly what that whole note would say. And you can compare that with the original information from your spec sheet. So that's how you can work on creating holes in OnShape. One thing you'll want to do is make sure that your sketch is visible, that has all of your center points on it so that you can make your next hole, and so on.